Imagine a world where drones deliver your packages, survey disaster areas, and even assist in firefighting, all without human pilots. Drones, once simple remote-controlled devices, are now sophisticated tools capable of autonomous decisions and complex operations. Initially used for military surveillance, drones have branched out into numerous civilian applications, thanks to significant technological advancements. These advancements include enhanced battery life, improved sensory capabilities, and greater autonomy through artificial intelligence. The drive for better, more efficient drones stems from a growing demand in industries such as agriculture, logistics, and emergency services. With a clearer understanding of the current state of drone technology, let's explore the specific advancements that are setting new standards in the industry. These innovations are not just expanding the capabilities of drones, but are also setting the stage for a future where the sky's the limit. One of the most significant advancements in drone technology is the integration of artificial intelligence, AI. AI-driven drones can analyze their surroundings, make decisions in real time, and learn from each experience, which is crucial for applications in unpredictable scenarios like natural disasters or complex surveillance missions. For instance, drones used in wildlife monitoring can now autonomously track animals in dense forests without losing sight of them, thanks to advanced AI capabilities. By automating routine tasks, drones can be deployed in swarms to cover large areas, whether it's for planting seeds in agriculture or searching for survivors in search and rescue operations. This swarm technology, powered by AI, coordinates multiple drones to work together seamlessly, thereby multiplying the effectiveness of individual efforts. As AI technology continues to evolve, the autonomy of drones will only increase, opening up even more possibilities for innovative applications. Battery technology is a critical component that dictates the viability and effectiveness of drones. Recent breakthroughs in battery technology have significantly extended the flight times of drones, which is crucial for tasks that require prolonged periods of operation, such as environmental monitoring or long-distance delivery. Innovations such as higher-density battery cells and more efficient power management systems have doubled, and in some cases tripled, the operational time of drones compared to just a few years ago. One of the standout innovations in drone battery technology is the development of lithium-sulfur Li-S batteries, which offer a higher energy density than traditional lithium-ion batteries. Moreover, the integration of solar panels into drone designs is another exciting development, particularly useful for daylight operations. As these technologies continue to evolve and mature, they will enable drones to perform longer missions, travel greater distances, and carry more weight, thereby expanding their potential uses across numerous industries. Section 4. Superior sensing drones that see more. Modern drones have sensors like thermal imaging, LiDAR, and multispectral, capturing data invisible to the human eye. In precision agriculture, drones monitor crop health by analyzing light reflected from plants. Thermal imaging helps drones detect heat sources, crucial in search and rescue. LiDAR uses pulsed laser light to measure distances, providing accurate 3D Earth data. Advanced sensors make drones essential for precise data collection in various industries. Section 5. Drone applications, transforming industries. Drones are transforming industries by undertaking tasks that are dangerous, expensive, or impossible for humans. In agriculture, drones plant seeds, spray pesticides, and monitor crop health. In logistics, drones revolutionize deliveries, with companies like Amazon leading the way. Drones deliver medical supplies to remote areas, improving response times. In disaster management, drones gather vital information quickly and cost-effectively. As technology develops, drones will bring more innovative uses and change industries. Section 6. Ethical and regulatory considerations. As drone technology advances, it brings with it a host of ethical and regulatory challenges that need to be addressed to ensure responsible use. Privacy is a major concern, as drones equipped with cameras and other sensors can inadvertently or intentionally collect personal data without consent. Regulatory frameworks are also crucial for maintaining safety in airspace shared by drones and manned aircraft. The increase in drone usage necessitates robust systems for traffic management to prevent collisions and ensure safe operations. Ensuring that drones are designed and operated in an environmentally friendly manner is essential for sustainable integration into everyday life. Addressing these ethical and regulatory issues is vital for the continued growth and acceptance of drone technology. Section 7. The future of drone technology. With ongoing research and development, drones are set to become smarter, more autonomous, and more integrated into various sectors. Emerging technologies like 5G will further enhance drone capabilities by providing faster, more reliable communications, essential for complex operations requiring real-time data transfer. This will enable more sophisticated and coordinated drone operations, potentially leading to scenarios where drones are as common as cars in terms of transportation and delivery services. Whether it's aiding in large-scale environmental conservation projects or providing new forms of entertainment, drones are poised to have a profound impact on our future. By embracing these advancements and addressing the accompanying challenges, we can ensure a future where drone technology plays a pivotal role in shaping our world. The sky, indeed, is no longer the limit.